Welcome to Use the Types Episode 10, HTML Templating with Ginger. In this video, we're going to take our Snap web app and we're going to add a dynamic HTML view. We're going to use the Ginger package for templating. Without further ado, we'll open up the terminal. We'll go to our src directory. We'll create a new project directory with a standard name, and we will grab a snapshot of the source code from our previous video. Here we go. Use the types 9 cleanup. There we go. Initialize a Git repo, add the sources, and you will recall we talked about this dev script which we used to build Intero and install GHCID for development on our project. We'll run that. That might take a couple of minutes to run. So while that's running, we'll open up another tab of the terminal, and we'll take a look at our views directory. And we see there's an index.html, which is the HTML file we created a few videos back to load up some JavaScript and a style sheet and provide placeholder div for the JavaScript. And in that same directory, we're going to create a new file, which will be a template. And we'll do it like so. So this cat command will add all of this content to this file, views/_info.html, and I'm adopting the naming convention of an underscore at the beginning of the file name to indicate that it's a template. Without an underscore up here, we have just a plain old HTML file, and the difference is that _info.html, while being mostly regular HTML, has these brace delimited placeholders, and this is Ginger syntax for string interpolation. So this means render this text and interpolate the value of title at this point. Ginger has other syntax as well for performing loops and other types of branching in the templates, which we'll get to at some point in the future. But anyway, we have our template now. Let's head back to our other tab. We see it's built Intero and GHCID. So now would be a good time to start up VS Code. So there is our editor, and in our integrated terminal down here, we'll start GHCID. There we go, it's listening on port 8000. Now, we're going to add a new route. We're going to handle the info route and have it invoke a handler called showInfo. So we're going to add a new element to this root list here. So this is a list, square brackets. Each element in the list consists of a pair. The first element is the path and the URL, so we'll handle /info. And the second part is the action to invoke when that path is encountered. And we're going to use some new stuff, some new things. Method get showInfo. And we'll split that onto a second line. We'll save it, and we'll see we should get a bunch of errors. So method is a function which combines with get, which is, I think, a data constructor for an HTTP method, to specify a handler which only responds to HTTP gets. It's more specific than just providing a generic handler. Now, they can be imported from snap.core. So let's just delete this explicit list of imports and save it, and that should allow us to grab method and get. Now, obviously, we haven't implemented showInfo yet, so let's go and do that. So the handlers for snap routes like this run inside this snap monad named monad snap with it's a monad transformer or something. M is the inner monad, which could be IO or something else, but it can be, we can keep the generic polymorphic definition like that. And it's going to be an action with no return value. And we'll define it as follows. We're going to use the send file function, which is another function from snap.core, and it yields or evaluates to an action which sends the specified file to the client. So we'll put the path of our info template and save it, and all being well, it compiles. Great. Let's open up that info route in the browser. So this is our top level route, which is the HTML that we saw before. Now we should be able to put /info on the end and we'll get our HTML sent to the client. And we can even view the source just to confirm. Look at that. So notice how it has not yet expanded the placeholders. So that's because we haven't actually hooked up any Ginger yet. So let's head back to our project. And we need to now plug in some new dependencies. So we'll open up our Cabal file, which is right here. And the new dependencies we're going to add are Ginger itself. And Ginger makes extensive use of the text package. And we're also going to use unordered containers. And this will allow us to create or use hash maps. And we're going to use hash maps to pass values into the template. So let's save that and let's see what GHCID does. And I'm expecting it to fail horrifically. Look at that, it did. Let's go and see what it's complaining about. So it says, while trying to build this, it cannot find Ginger. Ginger needed, but the stack configuration has no specified version. And the advice it's giving us is here, recommended action. It says to add it to the stack.yaml file in the extra depth section. And it's saying this is what we should add. So we can add this, although in practice you only really need this portion. The hash is not needed. So we're going to add ginger-0.8.4.0 into our stack.yaml file in an extra depth section. Let's do that. Let's open up stack.yaml. We'll add extra depths and an entry 0.8.4.0. We'll save it. I'm going to run stack build from the terminal with fast just to see if it can compile that. Look at that, it's grabbed it. So it's configuring, building, and adding Ginger to our project. Now I have built and installed this package many times before, so you don't see all the dependencies it's having to pull in, but I believe if you're doing this from scratch, there'll be something like 26 packages that Ginger itself depends on. They're already built on this machine, so this should be fairly quick. If you're doing this from scratch, it might take 5 minutes to build Ginger, depending on how fast your machine is, how fast your network connection is, and all that stuff. We'll let that complete. Actually, while that's doing that, we can head back to our project and we're going to create a new module under the source directory here. And I'm going to name it app. So we'll create a new folder using this button here, which creates a new folder directly under source, and we'll call it app. And I'm going to put a new module under app by right click on app and saying new file, and we'll call it template.hs. This is where I'm going to put all our template functions. So there we go, source/app/template. Let's open that file up. It's currently empty, of course. Oh, look at that. Ginger's finished, so we can now run GHCID again. Great. So we've added our new module. Let's add the module into our Cabal file. So this is our executable section. To do that, we would add a new section called Other Modules. And we'll put our new module in there. And we use its sort of fully qualified name, app.template. That's how you specify sort of hierarchical modules. Note, if I move this out of the way and hover over the name of the tab here, you'll see it's in source snap hello world /source/app/template. So the directory structure mimics the dot separated hierarchical format in the Cabal file. All right, now you'll see we've got some errors here, that the name of the module does not match the name of the file. That's because there's no text in here yet. So let's create a basic module. And I'm going to paste a bunch of code into here. Paste. There we go. We'll save it. And it all compiles. So I've created the module header, app.template. We're exporting a function render template. And render template is currently just going to do exactly what the show info action was doing before, which is evaluate send file applied to a file name. And so render template is going to be this general purpose helper. And let's look at the type signature to see what we're going to have to provide to this function. So it's all running in the monad snap m monad. File path is the name of the template path we'll pass to the function. Context, we'll look at that in a second, is going to be a sort of a collection of key value pairs in effect, which are used to expand the template, and it yields an action, m unit. Currently it ignores the context. The context here is a hash map of text to text, so it's just a mapping of strings to strings. This is the dependency on the text package that's in the data.text module up here, and hash map, which is from unordered containers. We're using the strict hash map here. That all compiles, great. We're not actually evaluating this function at all yet, so we'll head back to main.hs and we'll replace our send file call here with render template. Now if we save that, we're going to have some problems. First and foremost, render template's not being imported, so let's add an import. Oops, up here to import app.template. Save. That resolves the first error, but now we'll see there's a type error saying couldn't match m unit with unit. And this is because the actual type is context to m unit, but we're only passing it. So the expected type is m unit, sorry, which is the type here of show info. And this is essentially telling us that we're missing the context out, where we need to pass a context object here, like so. So we can use the hash map from list function to create such a thing. So we're going to use a $ and put hash map dot from list, and then an empty list. So that should create an empty context for us. Save that. We get an error saying from list is not being imported. So let's scroll up and add another import up here. Import data. Well, we're going to use a qualified import actually. Qualified data hash map strict as hash map. Qualified import allowing us to reference the from list function qualified with the name of the module. And let's provide an actual key value pair here. So the name of our tag, let's go back to our template, is title. So let's give it a title. Split this across a line, and we'll say title has the value info with capital I. That's the pretty title for it. Save. Let's see what we get now. Interrupted. Well, that's fun, isn't it? Okay. I think there's a race condition in GHCID. I see you do that from time to time. All right, so it's there, listening port on port 8000. Let's go and see what we see. Now, notice it's still giving us the placeholder. It's not expanding it yet. It's because we haven't implemented or provided a meaningful implementation for our render template function yet. So let's do that. So to do that, we're going to have to look at some of the functions in the text.ginger module. So we're going to end up importing text.ginger here. I'm going to kill GHCID and just run GHCI so we can look at the types of some of these functions. In the notes I provided links to some of the functions we're going to look at, but we're going to use parse.ginger file. We need to import text.ginger first. And we can do :T to get the type of parse.ginger file. I'm using tab convolution, by the way. And we can see parse.ginger file. There's a type constraint of monad m, so the sum type m, and we need to pass an include resolver, the name of a source file, which is source name, and then it will yield in m either a parser error or the template itself. So let's look at include resolver. I'm going to use info for that. And we can see that that is a type alias. It takes a source name, so it's going to be the same file name or the same type as the file name here, and yield a maybe source. in M. So this is a type alias for a function that is used to look up source files. And this is useful when templates reference other templates. In this first version of our program, we're not going to do that, but we need to provide the resolver anyway, even if it doesn't do anything meaningful. Although we'll write a version which will just look up files in the views directory or something. And then we're also going to render the template using easyRender. And that's got a rather complicated type signature, but I'm going to write some code here and it should all make some kind of sense. So we'll quit from there, we'll start GHCID again, and I'm going to give you a new improved implementation, and we'll talk about this a little bit. Save that. So lift IO, right. So parse_ginger file is going to do some IO stuff because the resolve function is just going to look up files on disk. Let's provide the resolve function while we're at it. So our resolve function, this is the include resolver, takes a file path and then returns the content of that template in IO. And so we use this, the standard read file function to read that, and if there is an error, if it throws an exception, we're going to catch that using try IO error, which converts read file which has type file path to IO string to a IO of maybe string. So we will get nothing, sorry, either. Well, let's go and look at that. Let's quickly. So that's in system.io.error. We can say, what is the type of try IO error? So you can see it takes an IO action of A and then catches the error and returns, evaluates to either IO error of A. So in fact, we will need to add the import for that. Import system.io.error. So this is a way of catching the exception and handling it sort of nicely in pure code. So we pattern match on MB contents, and if it's content string, then we yield just the contents. Otherwise, we print the error message and yield nothing. So this is our resolve function. We still have some errors. So to access or use lift IO, we need to import control monad IO class. That will give us monad IO. Look at that. Now, these modify response functions we haven't talked about much. They're all in snap.core. So let's do that. Oh, we've got some errors related to our strings, which are actually text. So we need to enable the overloaded strings language extension. Okay, compiles now. Let's review what we've looked at. So we've already looked at resolve. So render template is using the parse_ginger function that we looked at before, passing in this resolver and the path. And so this function evaluates to an action which uses this resolver to look up files in the file system and loads this template, this ginger, and parses it. And we're lifting it into IO because of this IO here, and we get the result. So if it's an error, parse_ginger file has either. If it's an error, then we will print E using lift IO, and then we'll modify the response to say server error 500. If it yields a valid template, we're going to modify the HTTP response to say content type text/HTML. So it gives a nice content type back to the client, and we're going to use easyRender, which is the function we looked at along with the others, which takes the context, this hash map, and the template, and then writes that text to the stream. That is our complete implementation. Let's take a look. It's listening port 8000. F5, there we go. It's expanded info in place. We have our first dynamic view. So in our next video and subsequent videos, we'll look at more advanced things we can do with Ginger.